I was going to originally do a talk about how observability is really expensive and we're all upset about it, but I feel like at this point we all know that. I thought I'd just do something else instead entirely. So you are now witnessing fresh material. How exciting. Okay, cool. Who am I? I suppose that's a really reasonably good place to start. My name's Chris. I run advocacy at CoreLogix. And like I say, thank God for psychological safety because I would not be here otherwise. The past 10 years, 11 years have been spent building applications, building platforms, both internally for external customers. I worked on giant container-sized batteries that run on the national grid. I blew one up. That's my claim to fame. It turns out that there's very few safeguards on the inverters of those things. It's how you start an electrical fire. It's wonderful. And I actually forgot what this QR code goes to, so just scan it and tell me. What does anyone scan it? What does it go to? Is it? Oh, that would have been great. Oh, is it? Oh, that's depressing. Okay, enjoy the CoreLogix landing page. The mission of today, we're going to get a bit nostalgic. We're going to start looking back on all of the things we've done. So just as a quick show of hands, who has been doing SRE or SRE, DevOps, operations, sysadmin, whatever? Who's been doing it for a year? At least a year, yeah? Who's been doing it for at least 2 years? 5 years? There were more hands for 2 years than 1 year. I don't think you guys know how cumulative things... Okay, anyway, 5 years? Okay. 7 years? 10 years? Okay, I'm sorry, guys. I don't want to remind everyone. Okay, so you're going to get some like NARM-style flashbacks as a result of this presentation. Essentially, we're going to start way, way back in happier and simpler times where we didn't have to worry. The word observability was something in control theory on the other side of the academic equation. In my very first job, I got my very first disciplinary I told the sysadmin guy to go away. I didn't say go away, but I can't say what I said here. So instead, use your imaginations. When you used to want to get a hold of a server, you used to have to bribe the sysadmin guy and be very friendly to him. Who was the sysadmin guy? Hands up if you were the sysadmin. Yeah. You got a lot of bottles of whiskey, right? Yeah. My guy. And this was really interesting because I remember when my first role, a 2-week turnaround was like cause for celebration because it was like you had to procure the blade, get it. You had to run all this automation to get it set up, plug it in. My favorite story of that place was that we had a streaming application that just kept crashing over and over again. It would come up, and then 2 minutes later, it would crash. The memory wasn't maxing out. Nothing was wrong. It's going, let's just go down. Let's just go down to the server room and see what happens. You're familiar with the idea of a hot aisle and a cold aisle? So you have the hot air blows out into an aisle, and it draws in air from the cold aisle. Someone had installed the thing backwards. So it was just drawing in from the hot. And so it was just overheating and crashing. Thank you, sysadmins. Thank you, this guy over here. So then we started having to work out what was going on with our logs. That was a big thing. It was like, how do I know what my logs are doing? I would have to SSH onto the server and then I wouldn't connect and I wouldn't know why. I essentially would stress myself out, and I was 20, so I could deal with the stress. And obviously it made us all feel like hackers when like our business-related counterpart were over our shoulders and we were on the console typing away and we felt great. How do you know all this? So you pick these things up over time. This was a really, really nice thing. And what was really great about this whole time, by the way, was that we had a lot of control and there wasn't that much data in typical applications. We weren't producing a massive amount. And then we obviously started maxing out file sizes, which was always fun. It turns out that 4 gigabytes is as big as it gets in a FAT32 system. Important fact. I learned this. I know the exact moment I learned this, as you can imagine, when the log file ran out. Like it just stopped producing logs 3 days ago, and this system was down and I had no idea why. This was why. So FAT32 has some limitations that you should know about, absolutely. I feel like I should have known this before this date after 4 years of a computer science degree, but there we are. And yeah, and obviously at this point, we basically said, if we roll over files daily, we'll never, ever have any issues ever again. And of course, we discovered a slightly more esoteric thing in the Linux operating system called an inode. Does anyone know what an inode is? Everyone, great. No, I just feel stupid. Okay, an inode is essentially a pointer to a file. You can only have a certain number of inodes. If you roll over your files too aggressively, you end up with lots and lots of log files that you don't clear out and you run out of inodes. Yeah, so that was pretty what I love is there's lots of nods here. Has anybody ever ran into that issue of running out of inodes? Yeah? And you run the command and there's loads of space on the disk, what's going on? And then you have to run df-i and you get the number of inodes and for some reason it's maxed out, yeah. I got this screamed at me across the office when I was like 20. A guy was like, it's run out of inodes. I said, what? It's an inode. It was great. That was the kind of stuff we used to have to deal with. We'll go a little bit more forward in time. We were here. So now, the advent of this wondrous thing, the cloud where I get to say bye to Gary, no more buying whiskey for people. I just click buttons and make servers and it's wonderful. And now AWS buys us the whiskey, but in small print with the money that we give to them. It's a roundabout way of doing it. The great thing about this, obviously, was that it unlocked the ability for us to get compute very quickly. I think when I first used AWS, it was about 6 minutes for the EC2 instances to come up. Now we're talking like a minute, 2 minutes. It's getting even faster. And obviously with containers and the extra levels of virtualization, things are getting even more efficient. What's fascinating about this, I think, is that it made it possible for a random junior engineer to spend an enormous amount of money with very little oversight. They were like, we'll have the cloud, because the business didn't really understand the cloud at this point. So they were like, we'll have the cloud and then some stuff's going to happen and we're going to make tons of money and that's how it's going to work. And their answer to that was to essentially give me a free license to do whatever I want. So I was spinning up these beasts and the apps never ran any faster. This is great. We were using, by the way, has anyone ever heard of Grails? So Groovy on Rails. Yeah? Hands up if you had a good experience with it. 2? Okay, 2. That is 2 more than 3. That's 3 more than usual, to be honest, because it's not great. The memory footprint's pretty heavy, and we had a real problem of just maxing out every server we had. And then obviously the cloud comes along, and I can, at a button push, spin up something that could run NASA. And of course, now my Grails application has never run any better. It's wonderful. And also, I wasn't involved in the building, so it was great. And then what happened was, when we got to the cloud, we had all these different servers and things. We started to realize that actually we need to be able to correlate between our data. And so just logs like it's broke lol is not really going to, as they say, cut the mustard. It's not really going to do it. And so this whole mission started of thinking about logs more like structured events. And they're in machine readable formats. They're very consistent. And what's most important about them, in my opinion, is that what this stopped us doing is thinking of them as files and started thinking of them as a stream of events. And this was, in my opinion, a bit of a watershed moment in the world of telemetry, in the world of observability, in the world of operations in general. Surprisingly, so my job now, I see dozens of companies or hundreds of companies, and the amount of logs that still look like this, where it's like system has failed, it's wonderful, like just great, but it's a complete dead end of investigation. And over time, I'm seeing more and more of a default sort of JSON thing. So just to prove the point, how many people log in a machine readable format like JSON? Yeah. You have to, yeah. What was that? This guy went, it's either JSON or it's not, mate. Is it JSON but escaped, or is it just a bit of this, a bit of that? Yeah, it's like a salad of various different machine readable formats. Wonderful. Okay. Everyone loves a bit of variety in their formats. That's what you want. Your data scientists absolutely love inconsistency in data. And then of course, metrics started to come about as well. I'm just on the cusp of understanding what was actually going on with the metrics sort of world in the past. And I remember when they first came about and I was like, but I can get all this from the logs. Why do I care? And then somebody showed me a PromQL query that actually transformed the data. And I realized like, oh, this is the difference between just combing through data and generating insights. And that's one of the things that metrics did. The other thing that metrics did was they are very low footprint typically. So you can have a massive amount of, let's say, you can cover a massive amount of your infrastructure with very little disk, memory, and CPU footprint, or comparatively a lot less than you can with logs. They're a lot less noisy. Metrics are lean by default. They're just number points with some labels. Now, of course, you can break that by putting IP address as a label on your metric, but there's no cure for idiocy. By the way, I had a really fun conversation with someone a few days ago, and he's like, metrics are just running so slowly on my Prometheus instance. I was, what's going on? How many Prometheus instances do you have? Which started a conversation, by the way, about what is the plural of Prometheus. Does anyone know? No, Promethei would be for Latin. It's not Latin, it's Greek. I didn't know this. I've been saying Promethei at conferences for years. Anyway, Prometheus apparently is the correct one, which is so boring. Promethei sounds fantastic, but alas, the language is never what you want it to be. Essentially what happened was we started to realize that we can have data in more lean, more efficient formats. That was the watershed moment of this. We started to really think quite deeply about what those format differences mean and what we can do with our data if we just apply a little bit of transformation, a little bit of optimization, that kind of thing. It's no longer just a file floating around. And of course, wrapped in all this, by the way, we started to aggregate logs somewhere along the line. I don't really remember when exactly that happened. I just remember swearing at Kibana a few times. Good fun. The next thing, of course, is where we are today. I decided to call this area the invoice is what, because I've been coming to these conferences now for years, and when I first started to come, the conversation was essentially around, oh, do you guys support this library? Do you guys support this platform? Now I have engineers who typically wouldn't care about cost coming up to me and go, wait, what's your pricing model? And it's because the economics has changed in the world. Obviously, we're in a slightly different position now than we were. The boom is very, very much over globally, for now anyway. And what's happening is that the companies are squeezing more. They're not just squeezing more in terms of profit, they're squeezing more in terms of risk as well. What tends to happen when there's less money going around is people don't want to change. People don't want to move so fast. And that's where we're at now. And it's really interesting because what we can start to think about is where we're going. So where are we? My app has 200 visitors a month. We need microservices. We absolutely have to have microservices. It's essential. This is the only way to build a modern infrastructure. My second disciplinary was for suggesting that we build a monolith. I'm deadly serious. I sat in a room and said, guys, this app does nothing. Let's just make it an app. And the manager took me out and said, this is your verbal warning. You're not playing ball with it. You're not being a team player. And I was like, your definition of being a team player is just blindly agreeing with whatever you say. But anyways, yeah, that rant aside, this isn't a therapy session, Chris. This isn't the fun of this was that it unlocked a lot of stuff. So I like to laugh at microservices a lot, but it unlocked a lot of really compelling things. One was, now I can scale individual parts of my application. The other, and the slightly more subtle one, which is a bit of a double-edged sword, is code quality. The impact of bad code wasn't quite as painful anymore because I can just put it, this microservice code base is shocking, but this one's lovely. And it's funny, but it's also interesting that the impact of bad code became a touch less, because if you had a big application, one piece of bad code here would pretty rapidly spread its way across. You have to be on top of it. In a microservices architecture, especially when each service has its own Git repository, for example, the spread of that bad code was massively stifled, which is fun because it started to legitimize dodgy code practices, but that's a different conversation. Really, the other thing that it did was it pretty much blew up this idea of architectural coherence, because architects would have these beautiful diagrams that were like, this is the service that manages all orders in the company, and this is the service that manages all payments in the company. And then after a while, it became like, this is the service that manages payments from a woman named Edith who lives at 567. We had the nano services approach to things. The thing that microservices did was it massively drove up the complexity, but it also drove up what we can do with our infrastructure. It wasn't a mistake as such. It's just, as with everything, every technical choice has a drawback. The drawback is that we have a lot more to track. My app has 200 visitors a month. We need to do microservices. Of course, my app has 200 visitors a month and 50 microservices. We need Kubernetes to manage all these microservices, guys. Who's using Kubernetes? Yeah, it's a big cube shop. Okay. This is fun. Okay, I asked, this isn't even part of the talk. Let's say you have to choose between serverless and Kubernetes. I know that the correct answer is like, whatever, you can pick the right tool for the right job. That's boring. Let's be reactionary for a second. If you have to choose Kubernetes or serverless infrastructure, it's all you can build with. You can't build anything else. Kubernetes, serverless. Oh, this is good. About 2/3 Kubernetes, 1/3 serverless. That's interesting. From my perspective, from coming at it from how we're going to track all of these kinds of things, the promise of serverless, of course, is that there's no servers to worry about. The reality of serverless is, of course, there are servers to worry about. You just can't see them, which is a bit of a scary prospect, but it's also from a liability perspective, it's amazing. Oh, it's not working. It's not my problem. Just message the account manager at Amazon. It's nothing to do with me. And so it's the thing of serverless is also a liability thing, which is bizarre because serverless is such a modern, cutting edge technology. But one of the big drivers that I saw, especially in some of the older companies that I worked at, was a liability thing. And it comes from the world of the oracles that would offer, we'll replatform your entire business and run it for you, and it'll just cost you £1 million a month. And this whole culture of we'll just shift the liability over there worked so nicely with serverless, because it's like, we'll just shift the liability of all of our servers and all of our computes over there, and we just have to worry about the dodgy code that the intern wrote. So essentially, Kubernetes has come about as a really interesting way of finding the kind of either the best of both worlds, or indeed the worst of both worlds, depending on how you decide to build it. And I feel like when I first started to learn about Kubernetes, it was pretty much against my will. It just appeared out of nowhere. I just attended conferences and learned things about Kubernetes. Words like pod appeared in my head a lot more often than they ever did before. Like I say, Kubernetes has been great, especially for the scaling and managing and the orchestrating of applications. It's very difficult to beat the level of functionality. However, it can get a bit intense when you're trying to work your way through, I have a pod, I have a deployment, I have some containers in the pod. This container came first. What does that mean? Who knows? And the volume is set and we have a persistent volume and it's got okay, so essentially it's tough. And what we need to do really is we need to start thinking a lot about bringing loads of tools in to manage all this Kubernetes infrastructure that we've made. And what's happening, I'm doing this in a slightly jokey way, but the point that I'm making is that all of these different events, they all play into each other. We start going to the cloud, and then we start building applications, and then we start moving microservices because we want to control individual components. And then to solve the problems of microservices, we need to have something to track all these different services, so we make Kubernetes. And now we've got Kubernetes. Oh, how do we work with Kubernetes at scale? We need all these different tools to make sure that Kubernetes is working. So it's very rare that you see a Kubernetes shop now without Helm, for example. It's very rarely you have crossplane for deploying different infrastructure. You can have various different CRDs and operators that you built, These things all play into each other. And what this does is it massively increases the field of complexity. And the way that manifests itself in technology and software engineering, especially from an observability standpoint, from a DevOps standpoint, is a lot more data needs to be produced because you have so many more places where things can go wrong. That's a message there. It's that you have a lot more failure modes, and so you need more sophisticated and more granular data, and that almost invariably drives up the volumes. So, and then of course this happens, and when the fall comes the party, it does indeed end rather abruptly. And yeah, this is where we're at now, is that we've had this really great run over the past decade of building and growing and new technologies, everything working into each other. It's working really well. And then, of course, the bill comes. And we're now, as an industry, it seems, we're all taking a bit of a deep breath and going, what's next? How do we tackle this growing problem? I can't tell you how we're going to tackle all of the problems of DevOps. I'm not that qualified, but I can talk a bit about observability to better understand what I think is coming, and then where I think the kinds of practices I think we need to have in order to solve those problems. What's next? We started to look ourselves at CoreLogix, actually, and we did some surveying, we did some analysis of usage patterns to better understand how people are actually engaging with the data that they have. What we found was that, just as off the bat, 30% of observability data that's ingested is never touched. Not that it isn't queried or it's never touched. It's ingested, it costs money, and then it goes, and that's it. It's essentially the me of stuff. No, the 99% of index data is never queried. The whole point of indexing the data is to be able to quickly query it, and yet it's never accessed, it's never queried. These are statistics that we found by surveying hundreds of companies, and we've done it. We just ran another survey of several hundred companies and found it's even worse now, which is crazy. 99% of queries on index data do not exceed 7 days. Just as a ballpark thing, who is generating logs? Keep your hands up keep them up. Yeah, this is a workout. Keep your hands up if you hold on to them for at least a week. Why are there more hands? You can't generate. Now 2 weeks, 3 weeks, 4 weeks. By hold on to them, by the way, I mean in a format that you can query them easily, like indexed kind of thing. Yep. 4 weeks, 5 weeks, 6 weeks, 7 weeks, 8 weeks. We're going to be. Do you want to just shout out? I feel like you're going to be here for a while. How long are you holding on to yours for? Yes, yeah, but typically they could be rehydrated. So you hold on to them and then you can have to be in, oh gosh, okay. I'm so sorry. Yeah, the average retention is 2 to 4 weeks. For this guy, 2 years. This is how percentiles work. The other thing is that observability these days tends to take up between 10 and 30% of your cloud budget, which is fun. Your whole product, your whole platform, and between 10 and 30% of it is spent just seeing what the hell's going on, which is fascinating. So when we found this, we were like, well, this is weird, especially since so many companies were talking about volume to us and they were concerned about that. And then we started to think, what are the actual practices? So less about the CoreLogix platform and the product and all the rest of it, but what are the practices that we can do as engineers to try to overcome some of those problems? And the big one we realized was that indexing is by far the most expensive thing that you will do with your data, because you're essentially holding very deep, very rich metadata about what you have. If you have 100 terabytes of logs, you have a few terabytes of metadata at least to manage that index, if not a lot more. And eliminating indexing from the equation became, or not eliminating, but making it optional, I suppose is a better way of saying it, became really important, became vital. And the essence of this is, how do we make it possible that data can be indexless, but still accessible? And we literally replatformed the entire company based on that principle. It's an architecture it's based on streams. We call it Streamer because everything has to have a name. And essentially the mission is to make it so that we can ingest data. It doesn't need to be indexed. It can be analyzed, generate alarms, generate metrics, update dashboards, be visualized in all the different features that you come to expect from a modern observability stack. So you need to be able to view a Kubernetes cluster. You need to be able to trigger alarms. You need to be able to view browser sessions in real user monitoring style. You need to be able to trace activities. You need to be able to view your serverless infrastructure. You have to be able to do these things. And not being able to do them is massive. But the question we asked was, can you do it without the indexing? And the answer was, yes, absolutely. You can definitely do it without the indexing. So at CoreLogix, what we do is you ingest your data, we put it into cloud storage in your account, and we query the cloud storage directly. With it being in your account, that means there's zero markup on the cloud storage. So you pay only for the cloud storage and you pay for your CoreLogix ingestion, and you're done. We can index your data for you for a set period of time if you want, but the message here is that you don't need to index. So when you're sending your logs to a SaaS provider or whatever, the question you always have to ask yourself is, does this really need to go into my highest performance, most expensive stack? Building that out will take some time. Building out that routing logic will take some time. If you want to do it yourself, more power to you. CoreLogix offers it out of the box. We have a bunch of features that actually support this, which I'm more than happy to show you at the booth or at the entrance, by the way. And that is essentially the history of DevOps and a little bit about where we're going. The data problem is very real. And this, by the way, is a TCO optimizer that actually allows you to declare where you want your data to go. Indexed, generate a bunch of stuff, alerts, metrics, that kind of thing, and then just doesn't go to the high performance index. It goes straight to your S3 bucket or whatever it is. And compliance, essentially, in 2 years, someone may ask me about what this person did on this date. Covering those different use cases is important. If you enjoyed all the terrible jokes and this general area, please, we're at the booth. This is a picture that was taken very recently. You may recognize the t-shirts. They're pretty recognizable. So if you want to come ask any questions about Indexless observability, I don't work in sales. So don't worry, I'm more than happy to talk to you about those problems anyway. But thank you so much for listening. Thank you so much for all the hands up and the participation. It's been absolutely brilliant. Cheers, guys. Thank you.
Thanks, Chris. I like how he put all of his development points in charisma. It seems to be working out for him. Do you have any questions at all?
Other than what is wrong with you?
Yeah, other than that. All right. It's 4 rows that way. Would you mind helping me?
Now is it on?
Oh, yeah.
Hey, there we go. So you talked about a lot of the problems that effectively, like the joke here of, okay, you have to do microservices. You have 200 people, right? I think the point that you're making there is that we start building everything for scale from the beginning.
Yeah.
And that's an absurdity. But like for most of our businesses, we're not successful unless we hit that scale. So it seems like the exercise here is we're starting eventual point. Is there a better way to do this based on what you've seen?
Absolutely, yeah. I'm a big fan of building the problem that's in front of you and the next problem that's down the line, not the problem that's 10 years down the line. So I'll give you an example. When I worked at that container, the battery, the energy company, we had very small scale. We were processing like a few gigawatts of energy, not gigawatts, gosh, a few terawatts of energy. It wasn't much, basically. It was only a little bit, few container batteries. And then suddenly we signed a deal and it was massive. If we'd have spent ages building out our infrastructure and get everything perfect up front, then we wouldn't have been able to make that deal because we would have been so busy making all these different changes to all this extremely complex machinery. We built it for the problem in front of us, and the problem in front of us was we have to get scaling. I think that the art of architecture is to solve the problems that are in front of you and give yourself options to move forward. It's always about giving yourself an escape route and never letting yourself get backed into a corner. That's the art of architecture, and doing that in the most cost-effective way. Nowadays, especially in the modern economic situation, the river of funding isn't quite the same as it was. So you don't have the time to sit and really deeply think about whether this should be a microservice or this one or this. Should this class really exist, or should we make it this? It's important. The craft of software engineering is still important, but the economics of it are much closer to it now. So that would be my kind of take on that. You're good?
How does the tool handle like real-time querying of large, like unindexed data sets without tanking performance?
Yeah, I can show you at the booth afterwards, but like essentially, that sounds like a proposition, I'm sorry. But essentially what we do is, I won't, it's a pretty storied thing. Traditional indexing would be, we'll track every single field and we'll track every single value of every single field. And then every time you make a query, we run it against that index and then we come out, and that causes a massive, what's called a mapping explosion. So what we do is we do what's called dynamic materialization, which is right on the cutting edge of data management. And we are constantly inspecting and adapting the format in which the data is held. Some of it's held in very high performance, some of it in slightly lower performance, based on query volumes, how often the fields appear, and so on. So what you'll tend to experience with the CoreLogix platform is you can query large volumes in seconds, and you can aggregate over massive volumes in seconds, like billions of logs in seconds. And the reason for that is because it's been optimized. when you first use it, it might be a touch slower, and by a touch slower, 30 seconds. And then as you move forward, it turns into 5 seconds, 10 seconds, and then becomes sort of 3 seconds, 2 seconds. Some of them are actually faster than the Elasticsearch clusters I've worked on, which is good fun. But yeah, so essentially I can show you, but we have a whole series of data science techniques that are proprietary to us, and we actually archive it in an open source format. It's archived in Parquet. So it's completely your data. You have complete access to it. But yeah, we've worked very hard on that particular problem.